Go ahead and get your names on this. All right. Every square matrix, n by n, has a related value called its determinant. Noted using vertical brackets. You know, usually a matrix, you have this kind of bracket, right? So 4, 7, 5, 2. That's the way, when you have a matrix, you have those, you have the top and bottom kind of taking those in. Now, I'm going to just write the words DET, like the determinant of this matrix is written this way. That's how you write the determinant of a matrix. All right? The determinant of a 2 by 2 matrix is the difference of the product of the diagonals. Okay? So, they actually had already done what I did up here, right? The determinant of this matrix, this is the way it's noted. You take this main diagonal, 4 times 2, and you subtract difference, the other diagonal, 7 times 5. So 4 times 2 is 8. 8 minus 35 is negative 27. Any questions on that? Let's do this one. So we're going to take the main diagonal, 3/2 times 8, and we're going to subtract the product of the other diagonal, 1/2 times negative 12. With me? Now 3 times 8 is 24. 24 divided by 2 is 12. Half of 12 is 6. What's a negative times negative? Positive. So 12 plus 6 here is 18. So the determinant of this matrix is 18. Any questions? Okay. We will try some of these later. Now that's for 2 by 2 matrices. 3 by 3, that gets a little interesting. So do you see this A, B, C, D, E, F, G, H, I matrix here? There is a technique for determining the matrix of a 3 by 3 matrix. And what you would do there is take this first column and write it right outside the matrix here, and then take the second column and write it out over here. So you kind of extend the matrix a little bit with 2 columns. When you're doing this, you are going the left diagonals, A times E times I, plus B times F times G, plus C times D times H. Those give you the product there. And then you get the right. And start at the far right. B times D times I, plus A times F times H, plus C times E times G. Figure out the left, figure out the right. Take that left number minus that right number, and you have the determinant of the matrix. Okay? Right now, I don't know if it makes complete sense to you or not, but I think it will if we do a couple of examples. All right, so let's turn this over. All right. So I have the 7, 3, 1, 2, 5, 6, 4, 1, 2 matrix that we want to take the determinant of. I'm going to put the 7, 2, 4 column and then the 3, 5, 1 column. All good? Now, the left value, I'm going to take 7 times 5 times 2 plus 3 times 6 times 4 plus 1 times 2 times 1. The right, you start at the upper right now. You guys with me? 3 times 2 times 2 plus 7 times 6 times 1 plus 1 times 5 times 4. All right. Now I'm going to do the calculations. 35 times 2 is 70. This is 72, and that's 2. So I'm getting the left value to be 144, if you guys have been calculating. You can check me on that. That's 12, that's 42, and that's 20. The right value, 54 and 20, 74. All right, the determinant is the left minus the right. It's 144 minus 74, which is 70. Yes. This would be a good thing for different colors, wouldn't it, Mrs. France? On. Okay. From yesterday, do you recall that the main diagonal is 1, everything else is zeros? In a 3 by 3, the main diagonal is 1, everything else is zeros? Identity matrix from yesterday. All right. Let's just do this real quick. Let's multiply 4, 3, 5, negative 2 by the identity, the 2 by 2 identity matrix. So I've got 4, times 1 plus 3 times 0. I'm just multiplying them together. And then I'll multiply these two. That's 4 times 0 plus 3 times 1. Get this one. 5 times 1 plus negative 2 times 0. And this one. 5 times 0 plus negative 2 times 1. All right. 4 plus 0 is 4. 0 plus 3 is 3. 5 plus 0 is 5. 0 plus negative 2 is negative 2. So what has happened? I took this matrix, multiplied it by the identity matrix, and what did I get? Got the same thing. What's that like in just the real number system? Yes. It's exactly like that. So this is like the number 1 with numbers, when you're dealing with numbers. So if I take 75 times 1, I get 75. If I take this matrix times the identity matrix, I get the same matrix. Okay? I don't know if you're good with that connection. All right. We're going to do this part, and then we'll do our practicing. And I want you to bring your packet in tomorrow. And we'll finish it tomorrow. All right? A matrix can only have an inverse if it's a square matrix. But not every square matrix has an inverse. Okay? Just because it is a square matrix doesn't mean it has a matrix. But it cannot have... Okay. Just because it is a square matrix doesn't mean... doesn't mean it has an inverse. All right. The product of matrix A and the inverse of matrix A, usually write the A with this negative 1 exponent. That's what the inverse, that's the notation for the inverse, is the multiplicative identity matrix. You made the video here, Jude. I said you made the video here.
Oh, cool.
All right.
Sorry.
Okay. So if I multiply matrix by its inverse, I should get, like on this one, what should I get? If these are inverses, what should I get? What should that answer be? Let's go ahead and give a spoiler. If these two are inverses, I'm going to multiply and I'm going to get what? Here and here, yeah. What's going to be here and here? The identity matrix. What is the identity matrix? You want to get this, right? If they are inverses. Okay? That should be our answer. Let's do it and see if it is. Yes? Pardon? I'm going to multiply this times this, and if I get this, then it is. Okay? So, I'm just kind of giving spoilers here. All right, let's do the multiplying. I'm going to multiply these two matrices together. So, first row, first column, 1 times negative 5 plus 2 times 3. First row, second column, 1 times 2 plus 2 times negative 1. Second row, first column, 3 times negative 5 plus 5 times 3. And second row, second column, 3 times 2 plus 5 times negative 1. Negative 5 plus 6 is 1. 2 plus negative 2 is 0. Negative 15 plus 15 is 0. 6 plus negative 5 is 1. All right. These guys are inverses. Okay? Because when you multiply them, you get this. You get the identity matrix. It's like, we'll go back to numbers. Multiplicative inverse of 3 is 1/3. What happens when I multiply 3 by 1/3? I get 1. 1 is kind of like this in matrix, right? 1 in numbers is like the identity matrix with matrices. Okay? Try this one and see if they are inverses. You guys seeing what I'm seeing here? I'll keep working. All right. I didn't get 1, 0, 0, 1. I didn't get that. So if I did this correctly, since I did not get that, the identity matrix, that means these two are not inverses. Does that make sense? Okay. Then